Hello, everyone. Welcome back to the channel. What is the logarithm of a number? A logarithm is fundamentally the inverse operation of exponentiation. If raising a number b to a power x gives y, then the logarithm answers the reverse question. Given b and y, what exponent x produces y? We write this relationship as shown on the screen. For example, since 10 to 2 equals 100. The base is 10, the exponent is 2, the number is 100. Therefore, log 100 to base 10 is equal to 2. Today, logarithms are more important than ever. They bridge algebra, geometry, information theory, and modern computation. A single idea from the year 1614 continues to shape the world. In computing, logarithms measure complexity, compress data, and stabilize algorithms. In machine learning, they appear in loss functions, softmax, entropy, and neural network optimization. The story of logarithms is a story of human ingenuity. A simple insight, turning multiplication into addition, transformed science, engineering, and technology. From predicting planetary motion to training neural networks, logarithms remain one of the most powerful tools in mathematics. Let's dive into the fascinating story of logarithms. For thousands of years, humanity stared at the sky and tried to understand it. But the heavens demanded something difficult: calculations. Long, exhausting, error-prone calculations. Multiplying massive numbers. Dividing by hand. Computing angles and distances across the cosmos. In Babylon, Greece, and the Islamic Golden Age, astronomers relied on vast tables of numbers. Every prediction of a planet's motion required dozens of multiplications. And as mathematics advanced, these computations grew only more complicated. By the 1500s, scientific progress was being slowed by arithmetic itself, such as the long, tedious multiplications. The world needed a shortcut. In 1614, a Scottish mathematician named John Napier introduced an idea that would change the world. His insight was simple yet revolutionary. Multiplication could become addition. Division could become subtraction. Instead of multiplying large numbers directly, Napier proposed a system where every number was assigned a logarithm, a companion value. And by adding these logarithms, one could multiply the original numbers instantly. Napier's idea spread quickly. One mathematician, Henry Briggs, saw the potential to refine it even further. He and Napier collaborated to create base 10 logarithms, the logs that would dominate scientific computation for centuries. Briggs published Arithmetica Logarithmica, containing thousands of logarithms calculated by hand, each number a gift to generations of scientists. With logarithms came a new invention, the slide rule. Invented by William Oughtred in the 1620s, it became the engineer's most powerful tool. For more than 300 years, slide rules powered inventions, from bridges to radios, and even the Apollo moon landing. Every calculation relied on one idea: logarithms turn multiplication into addition. In time, logarithms evolved beyond tables and slide rules. Mathematicians discovered the natural logarithm with a base e, tied deeply to growth, calculus, and the shape of the natural world. The newly discovered number e appears everywhere: compounding interest, population growth, radioactive decay, and the mathematics of continuous change. Today, logarithms are more important than ever. In computing, they measure complexity, compress data, and stabilize algorithms. In machine learning, log functions appear in loss functions, softmax, and neural network optimization. From digital audio to AI training, logarithms remain at the heart of modern technology. Even today, students encounter logarithms in new forms, with changing bases, system equations, and modern problem-solving techniques. Logarithms now serve as a bridge between algebra, geometry, information theory, and computation. A single idea from 1614 continues to evolve. The story of logarithms is the story of human ingenuity. A simple idea, transforming multiplication into addition, reshaped science, engineering, and technology. From predicting planets to training neural networks, logarithms remain one of the most powerful tools in mathematics. Alright, it's time to wrap up. What did you think of the story of the logarithms? Leave a comment below, and don't forget to like, share, and subscribe for more fun math stories. See you next time, and thank you for watching.